we've already looked at the surface area of a cone and the surface area of a pyramid. So if we look at a whole one, it would look like this. So a cone looks like this. But what would happen if we removed part of this cone, if we cut it from that point? What would we have? We would have a shape that looks like that. But is this shape defined? We cannot say that this is a cone, but we can say that this is part of a cone. If we did the same with the pyramid, which is rectangular, something like that. If we did something like that and then we removed part of this, if we removed part of this, we would also have part of the pyramid and part of the cone. So when we have such drawings or when we have such objects, we call them frustum. Frustum. So frustum coming from, it's part of something whole. So now I want us to look at the surface area of a frustum. So part of a cone, part of a pyramid. So that is what we'll be looking at in this area. If you look at that cone that we're drawing, we're having here, the part that I remove, is also a cone. The part that I remove is a cone. So what we do in getting the area of this, we have two cones. We have to consider the original cone and what we call the small cone. So if we look at the difference between the original cone, the whole of it, minus the one that we have removed, we are left with this part. So it's basically working on cones, but with a little tweak here and there to help us in getting this. I'll mention something. We have solid cones. Anytime a question talks of a solid cone, it means that after we remove our part, we are left with a surface like this. And a solid cone will have two bases, the top, and it will also have the base at the bottom. Then it will also have the curved surface. And for the base and the top, these are circles, pi r squared. I use capital R to represent the big one and small r to represent the top. So if it's a solid cone, it will have the top and the bottom. You have to read the question carefully and see what they're talking about. Then the curved surface now, this one is the one that we look for as the difference between the big surface area, the curved surface of the big cone minus the curved surface of the small cone. Supposing we also have maybe, let's say, a bucket that holds water. It looks something like that. But what do we know about a bucket? A bucket is open at the top. But look at its shape. It's a frustum. So this one also, we have to consider it, but we have to see that it only has the base, which is the small one now, pi r squared. Since this one is open, it's an empty space, then we'll also look at the curved surface area. So for an object that is open on one end, it only has one base, and then this one, the curved surface, will be given as the curved surface of the bigger one minus the curved surface of the smaller one. Another thing that comes about, maybe let me say this is a bucket. Sometimes it could also be a tumbler or something else with only one open end. And then there is something else we call a lampshade. And a lampshade is open on both ends. So it looks, it's a frustum, but it is open at both ends, unless the question says otherwise. But a lampshade is open at the end. And how do we get it? We get it as pi RL minus pi RL. Its surface area will be given as that. But our working is still the same, because for all of these, we have to complete to form the original cone. Even for a bucket, we complete it with a broken line to form the original cone. And as you shall see, we will have the height, vertical height, which is h. We'll have our r, and then we'll have the one which is leaning, which is L. So this is capital H, then this is our L. So when we talk, in case of a bucket, when we talk of the depth of the bucket, the depth of the bucket is the height from this point to this point. So it is the height of the frustum, and we do not use that height anywhere. As I've said, it is to get the surface area of this. If it's a solid one, you consider the top, the base, and the curved surface. So curved surface will be given as the curved surface of the bigger cone minus curved surface of the smaller cone. So there is nowhere where this is coming in, where this H is being used. This means vertical, this means slant. Do not confuse the two as we move along. So that is, in a nutshell, that is what we deal with when we are talking of surface area of frustum. If it were to be a pyramid, of course, you know, it has a triangular, rectangular, or a square base. Just that difference is what we would encounter, but most of them are solid. So also for a solid pyramid with a rectangular or triangular base, you'll still have 3 sides. But now the curved surface area will be given as the slanting edges of the bigger minus the slanting edges of the smaller one. So this one can be best understood by a question, and we have one. So we have this question. So we are having a cone of base radius 3 centimeters and height of 4 centimeters is cut off from a cone of base radius 6 centimeters and a height of 8 centimeters. So they want us to calculate the surface area of the frustum. One thing to note is that they are talking of a solid cone. So if it's a solid cone, it has 3 surfaces. It has the base, it has the top, and it also has now the curved surface. So what we do is we use the diagram as it is drawn. They're telling us that a cone of base radius, so the small cone is of radius 3 centimeters and its height is 4 centimeters, and it has been removed from a cone with a radius of 6 centimeters and a height of 8 centimeters. So if I draw, let me using half of that, this one to represent the bigger cone and this to represent the smaller cone, that the height of the bigger cone is 8 and the radius is 6. The height of the smaller cone is 4 and the radius is 3. Why do we do this? We do this because what we are interested in is not the vertical height but the slant height. From the formula we are talking of L and L. So from the big one, we want to get our capital L, the slant height. If you look at this is a right angled triangle. Therefore, we use Pythagoras theorem. Our big L will be given as the square root of 8 squared plus 6 squared. So L will be 64 plus 36, which means that L is equals to 100 centimeters. So L is 100 centimeters squared. Then centimeters. Then the square root gives you 10. For the small one, same formula applies. It's 4 squared plus 3 squared. So L is 16 plus 9. So small L is, let me use the one that looks like a stick. L. So the small one is the square root of 25, which gives us 5. Therefore, our capital L and our small l will be given as such. Now, what do we do then? What do we do then? So our surface has been removed, so definitely it will look something like this. After we remove the top part, this is what we'll be left with. So as I've said, we need the area of the top and we need the area of the bottom. So what is the area of the top? Is a circle. So we see area of the top, which is pi r squared. So let me call that area 1. So it's 22 over 7 times our radius. What is our small radius? The one for the top? 3. So 3 squared. You can say it's 9 pi. Let me use pi. It's 9 pi. Then area 2 is the base, which is also pi r squared. What is pi? Let me say pi times, what is our r? Big R, 6. We get that 6. So that is given as 36 pi. So we have the base and the top. Then the other part that is left is the curved surface. And the curved surface, I call it area 3. We've said the curved surface is given as the curved surface of the bigger one minus the curved surface of the smaller one. Therefore, it is pi RL minus pi RL. What is pi? What is my big R? My big R is 6. What is my big L? My big L is 10. So what is the pi is still constant. What is my small r? 3. My small l? 5. Therefore, we have 60 pi minus 15 pi, which should give us 45 pi. Then the total surface area will be area 1 plus area 2 plus area 3. Area 1, 9 pi. Area 2, 96 pi. Area 3, 45 pi. 9 plus 36, 45 plus 45, 90 pi. And what is the value of pi? 22 over 7. So definitely this is 90 times 22 over 7